Okay, in this chapter, there's a three subtopic. Okay, so we have 9.1, we have 9.2, and 9.3. Okay, so 9.1 is about pretty much about the simple harmonic motion itself. Most likely we'll be dealing about the physical quantities such as displacement, and then velocity and acceleration. Okay, and in the next subtopic, which is 9.2, we learn how to draw the motion in terms of graph. Draw SHM in graph, or maybe from the graph you can relate with the equation. It's a two ways punya ni lah, understanding. And then the last one is about the period. So the last one is it's a bit separate compared to others because of you have a specific formula and you can pretty much answer it using the formula straight away. So what I'm going to do today is that we're going to learn about this one, 9.1. And then after that we try to do some of the tutorial questions. And then hopefully tomorrow you can try to cover the remaining two subtopic, including the tutorial question. Okay, so far any questions that you want to ask? Ada apa-apa tak nak cakap ke?
No, sir.
So if there's no, maybe we can go straight away to the chapter. So what is simple harmonic motions? Siapa beritahu?
A system that doing a period motion or oscillation.
Okay, good. Ada few keywords such as oscillates, and then there are the period. And then if you look at your lecture notes and they give you a definition, I try to find it now. A periodic motion with a loss of energy. So maybe I can change. Oscillates is basically periodic lah. Periodic motion without loss of energy. Okay, and then one of the key things that also in the definition is that the acceleration. How about the acceleration?
Directly proportional to displacement.
It's directly proportional, so I'm going to show you, I'm going to use short form. Okay, and in fact you will see that the equation later on is negative x. Okay, the negative here actually defined as the direction of acceleration. So example, if you have a pendulum, a simple pendulum, that one is one of the example for simple harmonic motion. It undergoes a periodic motion, left and right, like that. If this one is the equilibrium position, we call this one as x equals to 0. So this is the equilibrium. Okay, yang tengah-tengah tu, between the minimum and the maximum displacement, we call that one as our equilibrium. So the displacement can be positive x and negative x. So on the right hand side, we assume that that one is positive x, and on the left hand side we assume that it is a negative x. Okay, apa maksud negative in terms of acceleration over here is that it means that the acceleration will always oppose the direction of displacement. A oppose direction of x. Okay, example, our x is going, let's say, di tengah turun kan, let's say it's going in this direction. Sorry, the displacement over here is on the left hand side, so it's a negative right? So this is a negative x, but the acceleration will always try to pull it towards the center. So a is positive, x is negative. Okay, and an example is over here. If the object is on the right hand side, your x is positive and the a will be negative because it's trying to pull towards the equilibrium. So acceleration punya direction always towards the equilibrium. So another thing is that without loss of energy, it means that the energy does not loss. So supposedly, in theory, if you have a simple harmonic motion, the object wouldn't stop at all. Dia memang tak akan berhenti sepatutnya. But in real world, ada friction, air friction and all, so dia akan berhenti lah eventually. Supposedly, they can keep on the motion. The energy transform from potential and kinetic, but there will still no energy loss lah. Okay, ada soalan so far?
No, sir.
Tak ada, sir.
Okay, so just now I showed you what is x. X here is the displacement lah. So in your syllabus, we have three main example for simple harmonic motion. One is a simple pendulum, that just now that I draw. Okay, another one we have a spring. See, we have horizontal spring. And then we also have a vertical spring. Biasanya horizontal spring tu normally they will say that there's a frictionless surface, so that there's no energy loss. Okay. And this one is called pendulum. Horizontal spring, and this is vertical spring. Sometimes they use this term dalam soalan sebab soalan biasa tak kasi gambar aja. So basically you have to draw it yourself lah. Especially for spring. Kalau pendulum tu dia memang macam tu. So kadang-kadang kata an object hang on the vertical spring. So you know that that one is a vertical spring. Macam ni the vertical VE
Ask the VE.
VE. So it will be VERTICL. Okay, so each one of these simple harmonic motion, dia mesti ada equilibrium position. The contoh, if I put the equilibrium position is over here, then that means yang below ni kita panggil dia sebagai negative x punya displacement. Above here is positive x. Okay, even though this one is basically y punya axis punya displacement, we still call this one as x. Dan bersin. Okay, tak jadi bersin. Macam nak bersin? Okay, so dulu old syllabus sometimes they use y and x and then student got confused. And must be dia nak pakai y, must be dia nak pakai x, so they got confused. So for your syllabus you don't have to worry. Everything, all the displacement we consider that one as x. Okay, kalau pendulum tadi kita dah ada, which is equilibrium x equals to 0. Anything to the right is positive x, anything to the left is negative x. It's simple, yeah. Horizontal spring will apply the same things. If this one to the right of the equilibrium is positive x, negative x to the left of the equilibrium position. Okay, this is when we are talking about the displacement. Okay, these are the key things such as period. So kalau period, I think you did the experiment already, so you know good. T is basically the period for one complete cycle. What does it mean by one complete cycle is that if you start from here, we complete one cycle back to the initial position. That one is one complete cycle, one oscillation. So the time taken for it to move from there back to the initial position, that one is one period. Okay, the same thing apply over here lah. From here it moves to the left, move back to the initial position, that one is one period. Okay, this one is for the three example that they might ask. Okay, sometimes they might give you a different one, but in general, it looks something like this. Okay, all this motion you can represent in terms of graph. Okay, secara ringkas, I will try to, you don't have to know the derivation of this formula. So we have a formula of A sine omega t plus phi. This formula, you don't need to know how to derive. Okay, into X. Untuk V dengan A, you have to know how to derive, but I just show you X first. Okay, for X, if you want to imagine, you can imagine something like this. As if I have my graph, sorry, this is my motion. Let's say it starts from the 0. Then it goes up, then it goes down. Then it goes up again, then it goes down again. Of course, it is actually going up and down at the same position, right? But we are trying to draw the motion in terms of time, since time is moving. So eventually you get a graph like this. So ini graph apa ni? Kau nampak tak graph apa ni? Naik positif, turun negatif, naik positif, turun negatif. What kind of graph is this?
Graph sine.
Yes. Okay. In this case, it is a sine. Okay. So that's why we have a general equation where we use the sine graph. Okay. The A here is actually amplitude. Okay. Obviously, you can derive yang inside here. You have to derive lah. But I think the easiest way is that you need to know that inside here is omega t plus phi. Dia sebenarnya datang daripada theta. And the theta, dia sebenarnya sin theta kan. Theta tu kamu boleh represent in terms of omega. So ada a little bit of derivation. You can refer to your lecture notes if you want to, but I'm not going to show it over here lah. Okay, A here represent the amplitude. So amplitude tu apa?
Dia yang highest point.
Yes. So maksud highest point tu, contohnya displacement paling besar. Kalau dekat sini paling besar, this one is the amplitude A. Okay. Kalau dia ke kiri, negative A lah. Kalau ke kanan, positive A. The same thing apply over here. Furthest to the right is the amplitude, positive. Furthest to the left is negative amplitude. Omega is actually angular frequency. Okay, sometimes they call this one as angular velocity. Is basically the same thing. And dia cuma nama je. Untuk kat chapter ni, sometimes kita panggil dia angular frequency sebab omega dia tu actually macam sebelum ni juga, sama je. Equals to 2 pi f ataupun 2 pi over t. Okay, the t here is actually the time, instantaneous time. So it is actually represent the time at that particular moment. The theta here we call as phase, phase angle ataupun phase constant. Okay, and the whole thing over here yang inside the sine ni, so we call this one as phase. Kalau yang ni phase constant ataupun phase constant lah. Yang ini adalah phase. Dia beza sedikit sebab yang phase constant ni dia represent berapa banyak dia tersasar daripada sine graph. Contoh this is a sine graph. Okay, let's say now your object starts somewhere over here, not exactly start at 0. So the difference here is what we call the phase constant. So that one you learn more in the next subtopic about the drawing and all. So it's enough for you to understand lah yang there's a difference between phase constant and the phase. The phase tu pula, it depends on time lah. So the whole thing is about at that particular time, berapa banyak dia punya phase tu dekat mana. Okay, and then one more important thing is actually the sign. Okay, this is the general equation, means that each one of these can change. Dia tak semestinya, amplitude tu tak semestinya satu, dia tak semestinya dua, dia boleh berubah lah, dia ikut graph tu macam mana. And dia adalah constant untuk satu objek, satu A. Omega pun sama constant sebab dia depends on 2 pi over T. T doesn't change. Okay. Phase constant pun constant, yang berubah hanyalah T dengan X yang sebenarnya. And then yang sine ni pun is a constant, tapi dia boleh selain daripada sine. It doesn't have to be a sine lah. So contohnya yang saya tunjuk tadi, kalau dia macam ni, dia jadilah sine. Okay. What happen when you actually pull the object below here and then release? So you will get the object, your displacement graph will look something like that. Kalau ni graph apa ni? Start daripada bawah macam tu. This is still wrong. Yes, this is actually a negative cos to be exact lah. Okay, good. So I think you get some ideas lah. Yang sine ni doesn't have to be sine. It could be cos, it could be negative cos, it could be negative sine. Macam mana nak tentukan? You really have to read the question properly. Okay. So kalau dia tak kasih soalan, dalam soalan dia tak kasih equation like this, they ask you to write the equation. Be careful with the sign ni, sebab kadang-kadang dia boleh cos, kadang-kadang boleh jadi negative cos. Okay, so far ada soalan?
Tak ada, sir.
Okay, the phase here, okay, good. The phase here is in radian. So you will expect your sign, you have to use radian punya mode. Okay, because they derive omega t ni sebenarnya daripada theta radian lah. Yang A ni, the unit will be the same with the X. So whatever the unit you have over here will represent the unit over there. Contohnya, if I use amplitude in cm, my X will be in cm as well. And then every time you write this kind of equation, you have to write down the unit. So how to write down the unit? You have to state lah, where X is in meter and T in second. So if you use SI unit, so this is how you should write it lah. Kalau X in centimeter, then you write X in centimeter. Okay, so this is about displacement. How do you want to relate displacement with velocity? Chapter 2, velocity dengan displacement. Apa kaitan dia? Apa? Macam mana nak kira velocity?
Differentiate.
Yes. Okay. So the formula V, actually, if you look at the definition, kalau dulu lah, dia ada delta S over delta T ataupun ds over dt. Okay. Now S here we use displacement with a symbol X. So you can differentiate. You can write down the formula dx over dt. Since our X just now is basically A sine omega T plus V. So if I differentiate this one, okay, yang ni kamu kena tahu macam mana nak derive. From X to V, you need to know, you need to be able to do that lah. So macam mana ni? Kalau contohnya yang ni, dapat apa? V sama dengan A berubah ke tak?
Tak.
Sine?
Sine jadi cos ke?
Jadi cos.
Sine jadi cos, okay. Yang dalam sine tu? Berubah tak?
Tak.
Tak berubah, okay. Lepas tu, ada apa lagi?
Angular.
Okay. Dia sebenarnya cara dia, kamu differentiate kan. Yang constant tu biar. Yang sine jadi cos. Dalam ni biar. Lepas tu kamu kena differentiate yang dalam tu pula. With respect to time. Ini yang sebenarnya lah, step by step. Tapi you can skip this one. Okay, since yang phase angle ni does not depends on time, so that one is just a constant. Kalau kita differentiate dia jadi 0. Time ni t kuasa 1, differentiate jadi t kuasa kosong, so jadi 1 lah. So you left with omega. So I can rewrite this one, V equals to A omega cos omega T plus V. Okay, this formula will not be given inside the formula sheet. Dia tak diberi. Okay, and then you have to be careful. So you don't need to memorize, but you just have to know how to get here, which is differentiate lah. You have to be careful with the starting equation. Kalau starting the sine, you will get the cos. Kalau starting the cos, kamu dapat apa kat bawah ni? Cos differentiate jadi apa? Negative sine. Okay, jangan lupa ya. Kalau sine jadi cos, kalau cos jadi negative sine, kalau negative cos jadi positive sine, negative sine jadi negative cos. Maybe saya boleh tulis kot kat sini so that kamu boleh ingat. So contoh d dt cos A kata contoh d dt sin A, d dt negative sin AT. Maybe saya tulis kat page baru kot. D dt negative cos AT. So this one is just a recap, revision. So if you differentiate a sine, you should get a apa ni? Cos kan? Kalau cos AT differentiate tadi dapat apa?
Negative sign.
Okay, good. Ini darah A lah. Kan? Negative sign. Sign differentiate jadi cos kan?
Negative cos.
Kalau yang ni negative so positive sign. Okay, put the A over here. Biasanya kita tak consider kat depan lah. Okay, so hopefully you guys can remember yang this one lah. So it really depends on the starting punya function. If it is in sine, you get cos. If you start from cos, then you get negative sign. Please remember that. Okay, that one is for velocity. So if the question asks you to find the velocity at a specific time, contohnya find the velocity after 3 seconds. So what you guys need to do is that you substitute the t equals to 3 seconds over here, and then you calculate everything, and you should get a value of v. Satu value je of v. At that particular time ada satu value. So that value represent the velocity lah, instantaneous velocity. So secara ringkasnya, this is a v at specific time. Okay, soalan kasih t, cari v pakai formula ni, ataupun kamu derive pakai formula ni. Okay, how about the acceleration? Macam mana nak cari acceleration?
dv over dt.
Okay, good. So acceleration A is basically dv over dt, ataupun change in velocity with respect to time. Okay, you can get this one by differentiate 2 kali daripada yang asal tadi. Kalau daripada x tu, kamu kena differentiate 2 kali lah, ataupun differentiate lagi sekali daripada equation sebelum ni. So this is the previous equation, A omega tu. I'm going to write it over here. Okay, ataupun kamu differentiate yang pertama tadi 2 kali. This is just how you write differentiation punya symbol lah. Nothing much pun. yang ni sebenarnya, bring it over here, this is actually d over dt. Okay, if you differentiate this equation, kamu dapat apa? A sama dengan A omega tu berubah ke tak kat luar tu, yang depan tu? So does it change?
Tukar, berubah.
Jadi apa?
Negative angle, negative omega square.
Okay, betul. Correct. Okay, very good. Okay, that one is more like you skip a few steps lah, which is good lah. Okay, yang step ni kamu tak perlu tunjuk, tapi saya tunjuk je in case kamu miss out. So A omega 2 actually dia constant, so it remains like that. Yang cos 2 jadi negative sine, so negative sine omega t plus v, and don't forget that you need to differentiate yang inside bracket tu once. Okay, and if you do that, you get exactly macam yang kamu cakap tadi, A omega sine omega t plus v. Okay, and remember that if you differentiate this one, you get omega. So end up you get something like this. Okay, this is what we call acceleration at specific time. Okay, so they give you specific time. After 3 seconds, find the acceleration. Okay, you can use this formula. Okay, ada soalan tak? Part yang differentiate tadi. Ada yang tak faham?
Faham, sir.
Okay, kalau faham tu, maybe you can move to the next one. Okay, this one if the question asks you in terms of time, right? But what if the question asks you in terms of displacement? Dia kata, find the velocity when the pendulum is 2 cm to the right of the equilibrium. So dia tak kasih time pun, dia kasih dalam bentuk, dia kasih dalam displacement. So obviously you want to write this equation in terms of displacement, in terms of x instead of t. Kalau yang ni tak ada x kan, so you want to change this one into x. So this one you need to know how to derive. Okay, sama macam yang B nya A tadi, yang ni pun kamu kena tahu macam mana nak derive. So how to derive that one, if you guys still remember, dekat sekolah dulu kita ada belajar kalau cos squared A plus sin squared A sama dengan apa? Pakai x kot dulu, cos squared x sin squared x dapat apa? Ingat lagi tak? Ni trigonometric identity yang 3 tu kan, ni yang paling senang tu. Ingat tak?
Tak ingat.
Tak ingat, sir. Tadi Google.
You should get 1. Okay, so ini I think at kot, sin square tambah cos square, you should get 1. Okay, but instead of x, saya akan tulis everything that is inside the bracket here. So what it means that I can write cos squared omega t plus v plus sin squared omega t plus v, and this one should equals to 1 as well. Okay, and if you want to substitute inside yang here, and so maybe you can write in terms of cos. So cos squared here is equals to 1 minus sin squared omega t plus v. Okay, and if you are looking back at the initial equation of x here, okay, this one actually I can rearrange this equation. Actually, saya boleh rearrange. So I can put this one as x over a equals to sine omega t plus phi. You guys agree with this or not?
Yes, sir.
Okay, kalau saya ambil square dekat sini, that means this one become x square and a square. Agree? Okay, atau kamu faham? Kamu faham? Boleh ikut ke tak so far?
Boleh macam tu sir, kuasa 2 tu.
Boleh? Maksudnya kamu square, okay, kata yang kamu tak nampak, dia jadi square kiri kanan lah. So basically this one, you take square on both side.
Oh, okay, okay.
Kan?
Baru nampak.
So kalau yang tu dia jadi atas bawah tu, saya boleh pecahkan lah. Actually kalau kamu tak nak pecahkan pun tak apa, tapi kamu letak bracket. Okay, that one, yang ni is actually exactly the same with that one, betul tak? Oops. Okay, so sebab yang ni sama, I can substitute inside here. So it becomes 1 minus x squared over a squared. And if I want to remove the square over here, sebab apa saya nak remove square tu? Sebab saya nak masukkan dalam ni, so that dia sama, exactly sama. So I have to bring the square to the other side so that it becomes a square root. Okay, and this one is just a mathematics lah. This one inside here, I can rewrite that one. Saya bersamakan penyebut dia. So this is basically 1 over 1. Okay, tak, saya tak buat apa pun. And then you can cross multiply, darab silang, samakan penyebut, dia jadi a squared over a squared minus x squared over a squared. Boleh ikut?
Boleh, sir.
Okay, since penyebut dia sama, saya bersatukan lah. A squared minus x squared. Okay, and best thing about the square root, you basically can separate kalau dia fraction. So you get down there as a, okay, and up here you get a squared minus x squared. Okay tak? Can you guys follow this one?
Okay, sir.
Okay, now this is about cos omega t tadi. So obviously I can substitute back inside here. Okay, so I substitute this one, so it becomes V equals to A omega, yang asalnya adalah so what I did is that I substitute the cos here, so you get okay, so you cancel out the A, the V now becomes omega square root of A squared minus x squared. Okay, since this one got square root, it can be positive, it can be negative. Okay, so boleh tak ikut apa yang saya tunjuk just now?
So far boleh, sir.
Boleh.
Boleh,
Jadi
sir.
jarang tanya benda ni. I think sejak perubahan matrix, maybe dia tanya sekali kot. Pernah sekali lah. For over 10 years, more than 20 years kot. More than 20 years dia pernah tanya sekali je. And maybe dia tak tanya, but then I couldn't, saya tak berani nak cakap dia takkan tanya sebab apa. Sebab dia ada dalam learning outcome. So basically you need to know how to derive. Whether dia tanya ke tak tu, it's a different story lah. And then so this one is for V. Okay, if you compare these two equation, yang atas dan bawah ni, okay, so this one is actually V, yang bawah ni pun V juga, tapi yang atas ni depends on time. Okay, number one, it depends on X. It depends on the question. You have to choose which one is the more appropriate lah. And this one is valid. Tak kisahlah dia asalnya daripada cos ke, daripada sine ke, daripada negative cos, negative sine. This equation will always valid untuk simple harmonic motion. Okay, tapi yang ni you have to be careful a little bit. Okay, sebab apa? Sebab kalau dia asalnya cos, dekat sini dia akan jadi negative sine. Yang ni you don't have to memorize. Okay, sebab apa? Dia akan berubah. Dekat cos ni dia boleh jadi sine, dia boleh jadi negative cos, dia boleh jadi negative sine. Okay, sebab tu formula ni pun tak ada dalam formula sheet. Tapi formula ni ada. So this one dia memang macam tu, dia tak berubah regardless of the position, the starting position pun. Just that this one depends on X. Kalau depends on time, you really have to do it manually. Kena derive lah, differentiate tadi. Okay, that one is for V. Now for A. Okay, if you guys remember, sin omega t plus V tadi kita ada buat kan? Okay, sin omega t plus V tadi, it's actually this one, X over A. Kalau tak square lah, kalau tak square dia jadi X over A je. So I can substitute inside here with X over A lah, so dia tak ada square pun. So A over here becomes negative A omega squared X over A. So I can cancel out the A amplitude, so I'm left with negative omega squared X. Okay, ini datang daripada definition tu balik. So benda yang kita buat sama ni nak prove definition tu lah. Again, you have two set of equation. One depends on time, another one depends on X. Boleh bezakan antara dua formula ni, dua-dua A, tapi satu tu depends on time, satu tu depends on X. Dan macam biasalah, yang ni kamu tak perlu hafal. Sebab apa? Dia boleh jadi sine, it depends on starting position lah. It doesn't have to be sine, so tu jangan hafal lah. Tapi yang ni you can memorize if you want to, but you don't have to sebab formula sheet is given. Okay, now we want to try to look at a few things. Okay, contohnya ni if you are looking at over here, X tu jadi maksimum masa bila? Equation ni, masa bila nilai X ni berada pada maximum value? You can see that
dekat maximum displacement.
dekat maximum displacement, which is at the amplitude. Okay, if this one is a sine equation, so basically value dekat sini dia berubah daripada 0, maximum dia 1, minimum dia negative 1. Okay, so X will be maximum when this one is equals to 1 ataupun negative 1, which is equals to the amplitude. Okay, kamu nampakkan dia idea tu. So dekat sini pula V ni akan maksimum kalau cos V ni equals to berapa? Sama macam tadi.
Macam mana sir?
V ni maximum value dia masa bila? The term over here becomes
Zero.
0 ke 1?
Tahulah.
Maximum.
Zero.
Kalau sini 0, 0 dalam omega, 0 dalam A, dia jadi 0. So V dia 0.
Okay, one.
Okay, 1 So kalau ini 1, ini adalah macam sebab cos dengan sin ni, dia punya value dia tak akan pergi lebih daripada 1. Maximum dia memang 1. So maximum value is when this one becomes 1. So I'm going to write over here. So take note V maximum over here when cos okay, which means that V max is equals to A omega. Okay, how about down here, yang equation bawah ni? V ni maksimum bila apa? Omega tak berubah, A pun tak berubah, X je yang boleh berubah. So, kalau saya nak dapat maximum values of V, nilai X saya ni berapa? Based on this equation.
Kosong.
Kosong. Kalau X 0, so that means saya ada maximum value dekat dalam bracket ni lah. Kalau X saya A, dia cancel out, dia jadi everything jadi 0. Itu V minimum. Betul tak?
Betul sir.
So, V max when X equals to 0. Yang mana V max will be equals to A omega. So, sama dengan atas ni. Okay. Which is true lah. Memang kita buat benda sama. So, in terms of drawing, katakan saya ada simple harmonic motion. So, this is my equilibrium. V maximum dekat mana? Adakah dekat position A, position B, ataupun position C?
B.
B. If we going back over here, when X is equals to 0, V maximum is over there. Kalau dekat A dengan C, V saya sama dengan okay, kalau confused, tengok balik equation ni. Kalau dia dekat A tadi tu, X saya sama dengan berapa?
Negative
Negatif apa?
1.
Negatif A. Sebab kita tahu amplitude dia berapa kan. So, negatif A lah. So, kalau negatif A, dekat sini dia jadi A, sebab square kan. So, dia jadi A. A square minus A square dia dapat berapa? A square minus A square. Dapat apa?
0.
0. Kalau ini dapat 0, V dia sama dengan
0.
okay, so kat sini saya nak tahu berapa? 0 lah kan? Tak faham
Tu sir.
Kalau dekat yang
betul,
belah ni, kalau dekat sini
Sama juga.
sama
0.
0. Okay, so you guys need to understand lah. Pendulum ni, kalau dekat ujung tu dia memang berhenti. Sebab tu dia equals to 0. At the maximum displacement, for a moment it will stop. And then it will go back to the equilibrium lah. So the moment they stop to is at maximum displacement at the amplitude and V equals to 0. V maximum dia ada dekat center. Okay, how about the acceleration? Tadi kita cerita pasal V, now we want to talk about acceleration. Okay, katakanlah saya punya acceleration dekat sini. We want to talk about this equation. Okay, masa bila A saya tu jadi A maximum, sama macam V tadi. So masa bila?
X sama dengan kosong. X
Okay.
sama dengan A.
Untuk equation ni tak ada X pun, betul tak? Yang tu bawah ni. Sekejap yang ni dulu. Bila sin ni jadi apa? Oops, mana pergi dia? Saya tertutup ni. Okay. Bila sin ni equals to Berapa maximum values of sine? Satu. Betul, satu. Okay, this one is very important. Saya rasa dah ulang banyak kali dah. I don't know why you guys macam tak dapat konsep sine dengan cos tu maximum value dia adalah satu. And this concept kamu bukan nak apply kat chapter ni je, kamu akan apply dekat the next chapter and the next few chapter. So it's really important for you to understand sine ni dia bergerak from 0 to positive 1 to negative 1, dia tak akan lebih daripada 1. Okay, so this one, when this one becomes 1, this is a maximum value. Faham ke tak?
Kurang.
Kurang? Kenapa tak? Apa kurang kat mana? Saya macam confused lah kamu tak faham kat mana. Cuba beritahu saya.
Kenapa ada kaitan yang ada cosine tu tadi dengan yang ni? Oh, maksudnya kalau acceleration dia apa? Dia depend dengan acceleration ke macam mana? Saya tak faham pula.
Dia, maksud saya kalau yang ni kan, yang saya tanya ni just now ni, actually saya tanya pasal equation ni je. Mungkin kamu bayangkan in terms of physical meaning. So physical meaning is more like displacement tau, which is bawah sini. Yang dekat sini dia tak ada displacement pun, dia tak ada cerita pasal X. So ignore dia punya physical meaning dia dekat position mana, just focus on this equation. Masa bila kamu nak dapat belah kiri ni maximum, kiri ni akan jadi maximum value kalau belah kanan equation ni jadi maximum. Okay, yang A dan omega ni tak berubah, so yang berubah hanyalah sign yang benda ni lah. So this value, if you press your calculator, dia memang tak akan lebih daripada 1. Dia minimum dia negative 1, maximum dia 1. So the numbers will vary from negative 1, 0 and then 1. So bila saya tanya masa bila kamu nak dapat maximum value sini sebagai maximum value, maksudnya saya nak dapatkan sini maximum juga. Sebab tu saya tanya masa bila yang sine punya ni kena berapa baru dia dapat maximum. Faham tak? Saya tak faham
Maksudnya sine tu kena sine tu kena jadi satu lah.
Yes.
Oh, okay.
When sine is equals to 1, itu adalah maximum values of A. Itu yang kita panggil A max lah. Sebab ada certain time dia kata cari waktu find the time when the acceleration is maximum. Okay, kalau dia kata cari displacement when the acceleration is maximum, you can use this equation. Tapi kalau dia kata time, you really need to consider this one. Itu yang masalah sedikit lah. Okay, anyway, hopefully you guys can understand. Kalau tak faham, beritahu jangan senyap, sebab saya tak sure kamu faham ke tak. Kalau kamu tak beritahu, at least sekarang saya tahu lah kamu ada masalah dekat situ. Yang lain okey ke tak?
Boleh
Boleh,
sir.
sir.
Boleh Okay, tak apa. Nanti kita akan jumpa lagi soalan. Hopefully we see a few more question about this and then maybe you can clear things out lah. Okay, how about yang equation bawah sini? A ni maximum masa bila? Okay, kalau equation bawah ni, omega ni tak berubah tau, sebab dia depends on the period ataupun frekuensi lah. It is a constant value. The only things that is changing is X. Value of X ni dia jadi maximum masa bila? Berapakah
Period.
nilai
Tak tahu lah.
paling besar? Sorry, X paling besar. Dah confuse lah. Okay, saya pergi balik kat sini. Okay, this one is when X is equals to 0. Bila dia dekat tengah-tengah. Okay, X ni dia berubah daripada 0, dia pergi ke X equals to amplitude, and dia pergi kepada X equals to negative amplitude. Okay, so maximum displacement is actually when it is at amplitude. Lepas tu dia patah balik lah. Dan dia pergi pula ke negative amplitude and then dia patah balik ke 0. So now my question again, A max ni masa bila? X ni sama dengan
Amplitude.
amplitude. Okay, and this formula is actually memang sama. So benda-benda dua-dua ni menerangkan benda yang sama. So A maximum is when it is at the amplitude. So we can go back over here to this diagram. So A max is when it is at over here. So dia terbalik dengan V tadi. Jika kamu tak faham sangat, you can memorize lah. So in fact when the X is equals to 0, A is equals to 0 as well, based on the equation. Okay, now you know the relation between the position and the V and acceleration. How about the energy? Okay, if I want to relate with kinetic energy depends on apa? Apakah faktor-faktor yang mempengaruhi kinetic energy?
Potential energy.
Okay, K sama dengan apa? Kinetic energy.
Harmonic square.
Apa? Saya dengan square je.
1/2 mv square.
1/2 mv square. Okay, considering that the mass doesn't change for this pendulum kan, so the only factor that is affecting the K is actually the V, betul tak? Velocity je yang effect daripada kinetic. So maximum kinetic energy bila velocity kita adalah apa?
Maximum.
Maximum. Okay, so kalau dekat diagram ni, dekat mana yang K maximum? Saya letak label dekat A, B, C so that you can answer it. So let's say put this is position A, this is position B, this is C. Okay, between A, B and C, mana satu K max?
B.
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 Okay, good.
B.
Betul? Jangan takut-takut nak jawab. Okay, masa bila K minimum?
A dengan C kan?
Yes, A dengan C. Masa dekat A dengan C ni, K dia berapa?
Kosong.
Kosong. Yes.
Kosong.
Yes. Okay. Okay, this one is about kinetic energy. Okay. So, kalau kamu ingat balik, di sana saya tak nampak saya padam. Okay, if you guys still remember from the definition, dia sebut yang energy is no energy loss. Betul tak? So energy ni tak hilang, dia hanya berubah bentuk. Okay, so you can see that the kinetic energy actually sekejap menaik, sekejap menurun lah. So dia sebenarnya berubah jadi energy apa?
Potential energy.
Potential energy. So maksudnya, katakanlah, okay, let's say I can write this one as E total equals to K tambah U. Okay, K here is the kinetic energy, U is the potential, E ini is the total lah. Katakanlah, let's say we put a number, total energy katakan 10. Okay, kalau kinetic energy 10, potential energy saya berapa?
0.
0. Okay, good. Katakanlah energy total saya 10, kinetic energy saya 0, potential saya
10.
10 kan? Kalau energy total dia tak berubah, masih lagi 10. Katakan kinetic energy 3, potential saya 7. Faham tak? Can you guys get this concept?
Boleh,
Maksudnya
sir.
itu total energy kan sir?
Total energy dia masih lagi sama. Maksudnya energy is conserved ataupun closed system, no energy loss lah. Dia cuma berubah bentuk je. Daripada kinetic dia pergi ke potential, dia pergi balik ke kinetic. And then at the same time dia boleh exist at the same time lah. Macam K dengan U ni dia dua boleh ada juga. Okay. Kalau okay, saya nak tanya kamu, masa bila potential saya maksimum? Dekat A ke, dekat B ke, dekat C? Maximum potential.
A.
A.
Lagi? Ada lagi tak?
C.
C. Kalau
Dekat A.
dekat B, U saya?
Kosong.
Okay. Faham ke tidak?
Faham, sir.
Faham So maksudnya dia salah satulah. Kalau K tu dah maksimum, U dia zero lah. Okay, sebab tu kadang-kadang soalan ni minta kamu cari find the total energy. Okay, there's no specific formula for energy total. Memang tak ada. But you can assume that at specific time kita boleh cari the K max ataupun U max. If you can find U max ataupun K max, that means you can get the total energy of the system. Kita assume lagi satu tu zero lah at that particular time. Okay, so the energy here, you can represent this one in terms of graph as well. Okay, saya tu lukis kat bawah dia. Okay, so graph of energy tadi, down here is the displacement x with respect to the equilibrium position yang kat tengah tu. Okay, let's say this is the energy total punya graph. So energy je lah, I put just energy. Okay, J. So the unit is J. Let's say this is the maximum amplitude and minimum amplitude. So I have to label as positive A. Positif tu tak letak pun tak apalah. Saya letak sebab nak bezakan dengan negative A. So in question biasanya kamu label A ni dengan nombor lah. Berapa meter? 3 meter ke 5 meter ke apa. Tapi ni sebab tak ada nombor, saya letak A lah. And then kalau kamu tengok in terms of K, kinetic energy, dekat tengah-tengah ni the maximum, dekat kiri kanan ni dia zero. So actually it will look something like this. Sini maximum, sini minimum. Agree or not?
Agree.
Agree, yeah? So if I want to draw, the graph would be something like this. Okay, that one is for kinetic energy K. For the potential, it is actually opposite. So means that dekat ujung tu dia adalah maximum, dekat tengah tu yang zero. So for potential, sini zero, maximum, something like this, kan? So the graph would look like this. Okay, boleh terima ke tak?
Oh, dia terbalik sir.
Dia sebab dia macam bergila-gila kan. Dia macam satu tu naik, satu tu turun.
Oh, maksudnya turun. Yang masa nak dekat tengah-tengah tu, maksudnya satu tu yang atas tu ke sir? Ke macam mana? Satu oscillation ke? Ke macam mana?
Dia macam objek tu, katakan pendulum tu kan macam ni kan, dekat tengah kan. So kalau masa dia bergerak ke kanan, kinetic energy dia eventually akan jadi zero sebab dekat ujung ni dia berhenti sekejap. So masa dekat sini potential dia maksimum. Okay, kalau kamu bayangkan pendulum kan dia naik sikit kan, macam ni lah. So dekat sini yang potential dia maksimum lah. Okay tak? So dia turun balik. So potential dia jadi zero balik, and then pergi balik naik sini. Potential dia maksimum balik dekat belah sini.
Oh, sebelah dia belah lah tu kan, sir?
Kiri kanan, kiri
Oh.
kanan. Okay, ini
Okay,
kalau pendulum lah. Let's say if you want to imagine, contohnya spring. Katakan kita nak imagine the spring. Katakan this is a horizontal spring. Okay. Applying the same concept. So, instead of gravitation potential, sekarang ni kita main dengan spring punya potential. Tapi dia still potential. Okay. So, kalau dia dekat sini, maksud dekat sini, dia paling banyak displacement dia. Compare. Ini equilibrium tau. Kalau equilibrium ni maksudnya spring tu, kalau kita biar panjang dia dekat sini je. Tapi kalau kita nak gerakkan dia ke sini, maksud kita kena compress. So, kita kena tekan, kita kena apply some work. So, those work tu dia jadi potential energy. So, dekat sini, potential energy adalah maksimum. Sebab apa? Dia punya displacement dia paling banyak daripada equilibrium. Okay. Lepas tu, bila dia lepas, benda ni akan gerak ke sini. Obviously, masa dekat sini dia berhenti lah. So, sebab tu kinetic energy dia zero. So, bila saya lepas, dia bergerak ke sini. So, slowly, kinetic energy saya increasing. But the potential tu decreasing. Sebab dia menghampiri equilibrium lah. So, dekat equilibrium ni, at this particular moment, potential spring dia zero. Okay, tapi kinetic energy dia masih ada lah, maksimum. Ni paling laju dekat sini. Lepas dia pergi ujung, sampai ujung, kinetic energy dia berkurang, eventually kinetic energy dia stop. Okay, K sama dengan 0 over there. So, when K is equals to 0, potential is at maximum. Ini dia patah balik ke sini. Okay tak?
Okay, sir. Boleh imagine.
Okay. Kalau pendulum tu memang senang nak nampak. Tapi spring tu tak ada rasa nak nampak pun. It's okay je. Okay, and then yang this particular ni macam saya cakap lah, dekat satu point ni kita panggil dia sebagai energy total. So, kalau kita berkira sama ada U maximum ke, K maximum ke, we will get a total energy. So, that one is actually something like this. You don't have to label yang dotted line tu, tak perlu label lah. Saya just nak tunjuk je. Sepada balik. Okay, ada soalan?
Tak ada, sir.
Okay, that one is pretty much about the theory for 3.1. Okay, you guys ready to continue with the tutorial question?
Ready, sir.
Alright. Okay, now I'm gonna start with the objective question first. So we're going to start with the question 1. So for question 1, kita baca belum soalan question number 1?
Dah, sir.
Okay, a mass on a spring undergoes a simple harmonic motion. The maximum displacement from the equilibrium is called apa?
Amplitude.
Yes, that one's easy lah. So if they ask if you have questions in UPS, maybe something like this you need to know lah. Simple je. Question number 2. Which of the following, bukan yang UPS 2 maybe UPS 3. Okay, which of the following statement is true about the magnitude of the acceleration for an object undergoing simple harmonic motion?
A.
Okay, it's directly proportional to the displacement. Okay, good. A. Question number 3. The periodic time T is given by
B.
okay, omega is equals to 2 pi over T, right? So T is equals to 2 pi over omega. B lah. Ball. Okay, the next question, question number 4. A mass in the diagram undergoes a simple harmonic motion when the mass reaches point X positive A, dekat sini lah, over here. The velocity is at maximum, minimum, tak ada, positif ke negatif lah. Velocity dekat ujung tu.
Kosong kan?
0. Yes.
Iya.
Okay, good. Oh, I see. Okay, hopefully you guys understand lah kot. Kita belajar apa tadi. Okay, very good, very good. Okay, I'm not going to discuss question number 5 objective because that one we haven't learned. I think we discuss it tomorrow. And now let's look at question number 6. Okay, question number 6, A and B, I think we already discussed in the previous one lah. Like, apa yang kita discuss today is about A and B, so I'm not going to discuss it again. But we can try to look at question C. The displacement of a particle undergoing a simple harmonic motion is given by x. Okay, they give you an equation. So maybe I can write down the equation straight away. X equals to 8 sine 4 pi t. Where x is in meter and t. So going back to this question, kalau kita dah compare between the general equation with the given equation, now you can take out the information lah, such as A is equals to 8 and then omega is equals to berapa ni? Omega sama dengan berapa?
4
pi.
pi.
Yes. Unit apa?
Radian.
Radian per
Kan.
second. To be exact lah. So it
Yes,
should be radian per
radian per
second. Okay, so first question, they ask you to write down the amplitude. So amplitude is 8 meter. The angular velocity, okay, sometimes they panggil angular velocity, sometimes they call it as angular frequency. It's basically the same thing. And then they want you to find the period of oscillation. So from the omega, you know that it is 2 pi over t, right? So t is equals to 2 pi divided by 4 pi, which is half. Okay, for question 4, saya tu dekat sini kot, sikit kot. The displacement when the t is equals to 0.2. Macam mana kita nak buat ni? Nak cari x when time is 0.2. So kita substitute dalam.
Substitute nilai.
Cuba tekan kalkulator kamu, berapa kamu dapat ni? Sebab saya punya kalkulator hilang. Tak tahu kat mana. So macam dekat. Entah, sekejap, saya tanya. Okay, berapa yang dapat ni?
Degree
Okay,
ya sir.
kena pakai radian sebab apa tu?
Okay.
4 pi 0.2 tu unit dia radian.
$4.7 meter.
4.70 meter. So it really depends on the unit of the amplitude tu lah. Kalau yang ni dalam sentimeter, find the answer dalam sentimeter as well. So in this case, dia dalam meter lah. Okay, moving on to the next question. Question number 7. The displacement of a particle oscillating in simple harmonic motion is given as x equals to, okay, so this is the equation. Find the maximum velocity of the particle. Macam mana tu? Dia kasih x. Okay, they want you to find the maximum velocity. Kamu nak baca ni? How you want to solve this one?
A darab angular velocity.
Okay, you can do that. You can use the formula of Vmax. Okay, so previously, okay, sebelum tu, maybe saya boleh simplekan something over here. Sekejap. Okay, so apa yang kamu belajar daripada tadi sebenarnya ada dua cara nak cari V dengan A. So basically kita ada X sama dengan ni general equation sin omega t plus V Right. And then you can find the V by differentiating this one, dx over dt. Okay. Sometimes example kalau kita pakai sine tu, kita punya V tu akan jadi A omega sine, sorry, becomes cos lah. Ni example sebab it really depends on the starting equation. And then kalau kita nak cari A pula, kita boleh differentiate lagi sekali, which is dv over dt. And example, in this situation, maybe we can get A equals to A omega squared. So jadi negative sine. Okay, ni apa yang kita belajar tadi lah. Okay, and at the same time, kita ada another option to calculate V and A, which is using the formula. Okay, kalau yang ni, dia jadi omega square root of A square minus X square. Betul? A square minus X square ke X square minus A square? Confused. So, be A squared minus X square, betul lah equation tu. Ataupun kalau untuk A, you can use negative omega squared X. Dalam kamu punya learning outcome ni salah equation ni. Salah. Mungkin saya punya version kot. Anyway, apa masa bila kamu nak cari yang kiri ni, when they give you time. Okay, the right hand side ni adalah position dependent. Okay, so kalau dia kasih time, you can substitute inside here. Okay, macam contoh soalan nombor 7 tadi. 7 saya ingat yang sebelum ni lah. Kalau yang ni X dependent, you can use this one. Betul tak? Agree tak? Now, can you guys see apa yang kita cuba buat sekarang ni? This formula is given in the formula sheet. Okay, so you don't have to memorize anything. Okay, this formula is not given, mainly because this formula might change. Okay, ini depends on that one lah. So this one is example. Okay, boleh tak bezakan antara dua ni? Can you differentiate, boleh bezakan tak antara bila nak pakai yang kiri, bila nak pakai kanan?
Boleh, sir.
Boleh, okay. So we are going back to this one, this question number 7 ni. Okay, sekarang ni kalau kamu nak pergi kat sini, you can try to solve using kiri dengan kanan pun boleh sebenarnya. Kalau contohnya ni lah. So just copy this one. I'm going to paste it over here. Okay, obviously you can use this formula. Kita bercari V maximum bila X ni sama dengan 0. Dia jadi plus minus omega A. Kan? Ataupun alternatively, since they give you X equation tu, kamu bercari V dia dulu punya equation. Kita differentiate betul? Kalau differentiate ni jadi apa? Macam mana nak differentiate? For sin omega t tu jadi apa? For sin tan pi t tu jadi apa? Mendengar suara saya?
Dengar, sir.
So jadi apa? 4 tu berubah ke tak?
4 tak.
4 tak berubah. Sin jadi apa?
Jadi cos.
Jadi cos. Yang tan pi t tu?
Tak berubah.
Tak berubah. Lepas tu ada darab apa-apa tak?
Angular kan?
Yes, darab dengan tan pi tu. Okay, so dia jadi V sama dengan 40 pi cos. Okay, and this one, dia adalah maximum V kalau yang ni jadi 1. So you can answer V max Okay, so ada dua cara lah kamu nak buat. So either you can use this formula ataupun kamu boleh differentiatekan ni sekali so that you get equation untuk V, and then you know that this one is basically the maximum. So dekat amplitude untuk V. Okay, that one for question A. Question B, find the velocity of the particle when the x is equals to 3 cm. Okay, kamu nak pakai equation ini ataupun ini. A ke B? Dia kasih displacement.
V equals to
Yes.
angular yang ada tu.
Sebab
Yang
apa?
agak
Sebab
pincang
dia
tu.
kasih X kan? So kita kena pakai yang tu. Okay, nampak Okay, B pula. V sama dengan plus minus square root. Oops. So obviously you have to take out the information first lah. Daripada yang asal ni lagi, kita dah beritahu yang this one, A sama dengan 4. Unit dia adalah centimeter. Oh. Kalau A centimeter, that means this one is centimeter. Be careful. And then we have omega, which is equals to 10 pi radian per second. So here you can solve. It becomes plus minus 10 pi. Okay, plus minus nak biar ke apa? Biar je. Right? And then if you press your calculator, you should get berapa ni? Berapa?
112 lah.
Depan dia apa tak dengar?
83.12.
Okay. 83. One, two. Unit dia apa? Centimeter per second. Okay, that one is for A and B. Now question C, they ask you to sketch a graph of velocity against t for this particle. Okay, graf kamu bentuk macam mana? Sin ke, cos ke, negatif sin?
Graph cos kan?
Betul, cos. Sebab tengok equation yang ni. So, kalau kamu jawab A dengan B pakai formula, dekat C ni pun kamu mesti kena differentiate so that kamu tahu graf dia graf apa. So in this case saya dah differentiate tadi. So graf dia adalah graf cos. Right, so cos bentuk dia start daripada atas lah. It will look something like this. Okay, we do have this value, so kena label. Kalau tak ada kena cari value of the amplitude for V, which is 40 pi dengan negative 40 of pi. Okay, and one of the important things over here, which is the period. Period ni dia tak suruh cari so far, so kamu kena cari lah sekarang ni. Macam nak cari period? This side. So the T is equals to 2 pi divided by 10 pi, which is 0.2. Okay, boleh ikut ke tak?
Boleh sir.
Now moving on to the next question, which is question 8. One end of tuning fork.
Sir.
Yes.
Sebelum tu kan, kalau dia bagi sentimeter, kita tak payah tukar jadi SI unit lah.
Boleh tukar, nak tukar, tak tukar pun tak apa.
Oh, lagi senang tak payah tukar kan sir?
Tapi be careful lah, so kalau tak tukar tu, make sure kamu guna unit yang tak tukar tu lah, which is centimeter per second. Rasanya macam lagi senang kalau tak tukar. Cuma jangan terlupa pula.
Okay sir.
So yang V ke X ni kan dia semua depends dengan equation unit yang amplitude ni. Kalau 4 tu dalam sentimeter, yang X ni dalam sentimeter. Kalau yang ni dalam meter per second, dan V ni pun dalam meter per second juga.
Alright.
Okay, question number 8. Okay, good question thank you. Sekarang ni dia kasih ayat pak. Dia kata simple harmonic motion, amplitude. Okay, yang ni kita maybe boleh pakai as a unit kot. So that tak pakai pun boleh, tak masalah. Ni kalau kita pakai lah, saya tunjuk kalau pakai. Period of oscillation is t equals to 0.001 second. Determine the maximum acceleration. Dan bahaya, sakit tekak. Okay, so basically dia hanya kasih amplitude dengan T, tapi dia cari maximum acceleration. Kita nak kira acceleration pakai
A max equals to A amplitude.
so dia tak ada kasih any time, dia tak kasih specific time tau. Yang time dia kasih ni adalah period. Ni period dengan time yang lagi satu tu berbeza lah. So A here is actually equals to negative omega squared X. Ni formula asal dia lah. Okay, sebab apa yang formula yang lagi satu tu dia tak beri tau, kamu kena faham sendiri. So A ni akan jadi maksimum kalau X tu sama dengan apa dia? Amplitude kan?
Yeah, amplitude.
Okay, so now kita masukkan je lah. Negatif omega. Macam mana cari omega?
Period dulu cari. Guna formula 2 pi T. 2 pi over T.
Okay, good. 2 pi over T. So, amplitude. Saya biarkan sekejap. Okay. Berapa dapat?
Nilai dia besar ni, sir.
Entah.
Dapat 19,739. Ke saya salah kira.
Macam mana? Ulang balik. Dapat apa?
19,739.
Betul. Okay, ceritakan degree. Kan kalkulator kamu ada DEG bukan degree, sorry. DENG kot. Sorry.
GNG. Oh, 19.73 darab 10/3.
Positif
Negatif.
Negatif. Okay, unit dia SI unit. So SI unit lah kat sini MS
Okay.
minus.
Maksud saya negatif semua tu. 10.
Okay.
3.
Tapi yang ni kuasa positif kan?
Sir.
Okay, jangan lupa letak negatif sini. So, adakah perlu biarkan negatif tu? Ya, biarkan je. Tak payah buat apa-apa. Okay, determine the acceleration when the displacement is 0.1 mm. Question B. Obviously, you still have to use this formula lah, so dia kasih position. So, kalau kamu kira omega tadi asing, then maybe you don't have to press your calculator again. Tapi sekarang ni, tidak. Tadi tak kira asing, so.
Sir, saya nak betulkan satu. Yang tu negatif 19.74.
Okay.
Saya lupa nak bunda pula.
Alright.
Sorry.
It's okay. Alright. Okay, yang B tu? Soalan B. Yang lain? Cerita? Terlelap ke apa?
Tengah tekan so.
Akan tekan. Tekan tak apa, jangan tertekan sudah.
Negatif 3.95
Okay.
darab 10 kuasa 3 meter per
3
second. Meter per second pula. Salah.
Betul kan? Salah?
Betul.
Betul, okay.
Betul sir. Acceleration.
Okay, B. Soalan C. Deduce an expression for displacement in terms of time. Assume that when t is equals to 0, the n is at the equilibrium position. Okay, maksudnya katakanlah dia sudah assume bila time equals to 0, objek tu dekat 0 juga. Okay, and then dia pergi ke kanan, ke kiri. Dia sepatutnya cakap details tau. Dia when time is equals to 0, dia dekat mana, and then after that dia pergi mana. Dia macam contoh kalau spring kan, kalau kamu tarik spring tu ke bawah daripada equilibrium position, bila kamu lepas, obviously dia akan naik ke atas lah. So benda macam tu kamu kena bayangkan dia kisah. Okay, we will learn this one more, this one deeper tomorrow. Tapi yang ni saya just tunjuk je. So maksud dia bergerak daripada sini ke kanan dan ke kiri. So kalau saya nak represent in terms of graph, okay, graph saya tu roughly dia akan pergi ke positif betul. So dia akan naik atas macam ni. Lepas tu pergi balik ke 0, dan pergi bawah, dan pergi balik ke 0. Don't worry lah, nanti esok saya tunjuk balik yang ni. So kalau macam ni lah, graf kamu ni, kamu nak pakai sin ke cos ke, negative sin ke negative cos?
Sin?
Yes, you use sin. So, it will be A sin omega t. Okay, yang phi tu kamu tak perlu pakai sebab kamu tahu dia memang exactly sin. Okay, katakanlah dia bentuk cos, tapi kamu nak pakai sin, and then baru ada nilai phi yang kat belakang ni. Okay, maksudnya lah, kalau dia memang rupa cos, kamu pakai cos, dia tak ada phi tu pun. So, nanti esok saya ajar sebab dia nak pakai phi. Perlu ke tak pakai phi? Anyway, this one is A 0.5 times 33. Omega ada berapa sebenarnya? Daripada tadi kita duduk tekan. Tapi kalau omega saja berapa? 2 pi bagi 0.01.
2000 pi.
2000 pi.
2000 pi. Okay. So you still have to write down where x is in meter and t in second.